My name is Shailesh Pawar, and today we are going to have a look at different data types supported in Java and the related programs. So I'm going to start sharing my screen now. Okay, so let's start. Now, first thing that we all know that Java is a language which is highly inspired from C and C++. So as far as data types are concerned, lots of concepts have been borrowed as it is from C and C++ in case of Java. So in case of Java, we have concept of primitive data types available to us, out of which the first data type that we are going to talk about is going to be byte data type. Now, when we talk about, see, data types are there, would always be used to specify what type of values are we, type of values are we going to store, and what range of values are we going to store. So when we talk about byte data type here, जब हम लोग byte data type की बात करते हैं तो इसकी जो size होती है, कोई भी बाइट टाइप अगर वेरिएबल हम लोग बनाते हैं तो वो मेमोरी में एक बाइट की साइज लेगा, एंड इफ इट इज गोइंग टू टेक अप 1 बाइट साइज, द रेंज of it is going to be from -128 to +127. So if we have a variable of the type byte here with us, then we can store any value from the range -128 to 127 in it, as the size of the byte data type is 1 byte. Okay, so after byte we are going to talk about the next data type, which is short. Now as far as short data type is concerned, the size of short data type in case of Java is going to be 2 bytes, and its range is going to be from -32768 to +32767. This is the range that we generally get in case of C and C++, in case of 16-bit compilers for integers, for int type values. But in case of Java, the short type value will provide us this particular range. So we have specified byte and short. Now the next type that we are going to specify here is going to be int type. And as far as int type is concerned, we have the size for any int type variable in case of Java is 4 bytes. So an integer variable, int type variable or int type value is going to consume 4 bytes of memory in case of Java. And as we are talking about int type here, obviously we are talking about whole numbers, and the range is going to be this much. So generally most of the times it happens that लोगों को जितनी भी values की या numbers की requirement होती है वो इसी range में fulfill हो जाती है, तो most of the times you would always end up working with integer type only. Still, if you would want to store data or say store the value, you know, which is much larger than this range, you can always go for a type called as long. हम लोग लॉन्ग टाइप के पास जा सकते हैं, तो हम लोग देख सकते हैं यहाँ पे इसकी साइज 8 बाइट्स है, और 8 बाइट्स है, तो लुक एट द ह्यूज नंबर व्हिच हैज बीन गिवन टू अस, है ना. आई डोंट थिंक कि इसके आगे मतलब इस रेंज नंबर से और कोई बड़ा नंबर की प्रोग्रामर को जरूरत पड़ सकती है. एंड इन केस अगर इससे भी बड़े नंबर की जरूरत है, then obviously there are classes named as big integer, and all other classes we will be seeing in future, obviously. So using such kind of classes, you would be able to store even the numbers which are larger than this range. But by looking at the range itself, we should be able to understand that it's a very huge range of values, which should suffice all our requirements. So these are the types which are related with whole numbers. As far as Java is concerned, we have byte, which is of the size 1 byte, short, which is of the size 2 bytes, int, which is of the type 4 bytes, and long, which is of the type 8 bytes. Now, after these types have been covered. The next type that we'll be talking about is going to be char type. Now this is where you are going to experience the change. In case of Java, char type की जो size है वो होने वाली है 2 bytes. Char type would be of 2 bytes. It's not it won't be of 1 byte. जनरली सी एंड सी प्लस प्लस में कैर टाइप की जो वैल्यू होती है वो तुम लोगों को 1 बाइट दिखाई दे सकती है, बट एज फार एज जावा इज कंसर्न कैर की साइज 2 बाइट्स होती है. तो ऑब्वियसली इसकी जो रेंज होगी, द रेंज इज गोइंग टू बी फ्रॉम 0 to 65535. This is going to be the range for char type. Now question comes up that sir शॉर्ट के लिए भी 2 बाइट की रेंज थी, तो आपने 2 बाइट की साइज थी, तो आपने उसकी रेंज -32768 से लेके 32767 ये बताई. और जब आप कैर की बात कर रहे हैं, इसकी भी साइज 2 बाइट से, फिर इसकी रेंज आपने निगेटिव से क्यों नहीं स्टार्ट की? बिकॉज एज फार एज कैर टाइप इज कंसर्न इन जावा में कैर टाइप निगेटिव वैल्यूज को स्टोर नहीं करता. Only positive values are stored, and that's why the range is from 0 to 65535. Now there is one important point here. Many of you would be wondering that is there any science behind calculating this range? I mean, is there any formula using which the range can be calculated? The answer is yes. You just have to take a look at the size in bytes. So let's talk about byte data type here. इसकी size 1 byte है, तो as we all know 1 byte means 8 bits. So then find out the value of 2 raised to 8. The 2 raised to 8 value would always be obviously 256, okay, which means using byte you would be able to represent 256 values or 256 numbers. You would have to divide 256 by 2. The answer would become 128, and that's why the range would be from -128 to +127. If you would count the total number of values from -128 to +127, you would get 256 values. As we want to represent negative numbers, we are dividing the 2 raised to 8 final value by 2, and then we are calculating our range. This is the scenario which is applied in case of all the types. Obviously you are not going to get questions regarding the range of type or how a range of type is calculated, but yes, अगर पता होगा तो अच्छा ही है, इसलिए मैंने तुम लोगों को बता दिया. तो सेम इज द सिनारियो फॉर कैर. अगर 2 बाइट्स है, मतलब हाउ मेनी बिट्स? 16 बिट्स. तो 2 raised to 16 का जो आंसर है वो आता है 65536, which means 65,536 values would be represented using char. But as we are not going to represent negative values here, we are not going to divide it by 2. Rather, we are going to consider values from 0 up to 65,535. If you would count, you would get 65536 different values being represented. That is the way in which the range has been calculated here. So for char, we have this scenario. Now, when we talk about float, in case of Java, the float type would require memory of 4 bytes, and this is considered as sufficient for up to 6 to 7 decimal places. So as we all know, when we talk about float, we are talking about fractional numbers here. So after that decimal point, to the right hand side of the decimal point, कितने numbers की accuracy अपने को मिल सकती है यहाँ पे हम लोगों को? तो up to 6 to 7 places की accuracy यहाँ पे हम लोगों को मिल सकती है. When we talk about double type, when we are going to talk about double type here, size would obviously increase. Double is going to be of the size 8 bytes, and double is going to be sufficient for up to 14 to 15 decimal places. So we are going to get such a high accuracy using float and double. So this is about fractional numbers, and once we are done with fractional numbers, then we are going to talk about Boolean type here. Now we will have to understand one thing, that Boolean size for Boolean type is not specified in case of Java. Now this is such a type in case of Java, जिसकी size है ना, JVM to JVM it might change because Boolean type is very much architecture dependent. So it all depends on what JVM you are using. So size of Boolean type is obviously not specified in Java, as we all know. Boolean type is used to store values like true and false. You know, these are the only two values that you can store there. So as such, the size of Boolean type doesn't matter, because you would never be counting or finding out any range of values to be stored in case of Boolean type. So this is about the primitive types which are available in Java. So we started with byte. Byte is of 1 byte, then short of 2 bytes, int of 4 bytes, long of 8 bytes. Then we have char, which is of 2 bytes, float, which is of 4 bytes, double, which is of 8 bytes, and boolean. So in all, boolean, double, float, char, long, int, short, and byte. So these are the 8 primitive types which are available in Java. तो ये 8 primitive types है जो Java में हम लोगों के लिए यहाँ पर available है, हम लोग जिनको use करते हैं. Now along with these primitive types, in case of Java, we have concept of wrapper classes also. And wrapper classes are going to be such classes which represent, using which all these primitive types can be represented in terms of classes in Java. See, in a way, Java people knew that there would be some critics who would start complaining that as Java is an object-oriented language, it should have represented everything in terms of classes and objects only. But Java people knew that Java people always wanted as existing C and C++ programmers to migrate smoothly to Java, and that was the reason why they decided to keep the concept of primitive type available in case of Java. But in order to satisfy the programmers who wanted everything in terms of object orientation, they have given us the wrapper classes also. So wrapper classes are the classes which represent each primitive type available in Java in terms of classes. So as far as wrapper classes are concerned, all of those classes belong to java.lang package. So for byte primitive type available in Java, we have corresponding java.lang.byte class. Then for short type, we have corresponding short class available here. I'll just copy this thing. Then for int type, we have corresponding integer class available in java.lang package. For long type, we have long class. For float type, we have float class. For double type, we have double class. For char type, we have character class. And for Boolean type, we have Boolean class. So all the primitive types available in Java are being represented in terms of classes also in Java. Now, in a way, Java people have left it up to programmer to decide which particular which particular type they want to follow, whether programmers want to stick with the primitive types or they want to make use of wrapper classes in their programs. Obviously, we are going to cover up wrapper classes in case of advanced Java kind of syllabus. We are not going to cover those use of wrapper classes in this particular course. But you people should be knowing about, or should have this idea. Being a developer, you should have this idea that wrapper classes are also available in case of Java. So once we have understood this, now let's understand how are we going to make use of all these classes in our code. देखते हैं अब इन सारी चीजों को हम लोग अपने कोड्स में कैसे यूज करेंगे. ठीक है. So let's open our previous program in Notepad. Okay, so this is the program. Now I'm going to write certain code here let's see how Java treats each type. Let me make the changes first. Now let's start writing the code. The first part that we are going to see is going to be something like this. Say I've said int x equal to, or say I've said double x equal to 4.5 here, and then I'm going to say int y is equal to x. And then I would like value of y to be printed on screen. I don't want that import statement here, so I have just removed that statement. Now have a look at this program. We have declared one double variable here, x, which is containing value 4.5 in it, and now I'm assigning this x into a variable which is of the type integer, int variable. So in short, I'm assigning a double type value to an int type variable, and finally we are going to print that int type variable on screen. Now the people who have come from C and C++ background, if I would ask them the question that what is going to be the answer here, most of them would say that final answer is going to be 4. Your y is going to contain the value 4, because in case of C and C++, implicit type conversion sort of thing happens, and C and C++ compiler would simply allow this, considering that the fractional part is to be removed, and only the whole number, that is 4, is to be assigned into y, because y is of the type integer. So, and we all know that integer can accept only whole numbers. But this is not going to be the scenario in case of Java. Java is comparatively more type-safe language than C and C++, and more sophisticated language also. So now let's compile our program and find out whether Java compiler is going to allow this program to be compiled or not. So I'm going to compile this program now, and definitely we are going to see a compile time error here. As you can see on the screen, a compile time error is being displayed, where the compiler is clearly saying that there are incompatible types available in this statement, possible lossy conversion from double to int. Now let's understand why this thing is happening here. As we can clearly see, we have assigned value of x to y. X is a variable of the type double, which is getting assigned to int, and Java compiler knows that if this assignment is to be carried out, the fractional part is to be removed from the value 4.5, and this is going to result into loss of data. And always remember that by default Java compiler will not allow lossy conversion of data. Java compiler would never allow this, and that's why at compile time only, we are seeing this error, because you are going to lose the data, and at times when developer or say user loses data, it might have adverse effects in the final output of the program. So Java compiler is very much aware of this scenario, and that's why we can see that it is being clearly specified here. It is being clearly shown here that we cannot do such type of conversion. ओके, सो अब क्वेश्चन ये आता है यहाँ पे कि हम लोग इस सिनेरियो को अवॉइड कैसे कर सकते हैं, या तो अवॉइड करना है तो ऑब्वियसली हम लोगों को ये रूल ही पता होना चाहिए कि अगर तुम लोग डबल वैल्यू को y में इंटीजर टाइप में असाइन नहीं कर सकते, और उसके पीछे एक रीजन भी है. ऑब्वियसली रीजन वी ऑल नो दैट डबल इज गोइंग टू बी अ टाइप whose size is 8 bytes. ये हम लोगों ने देखा था यहाँ. डबल की साइज 8 bytes होती है, whereas integer is going to be the type whose size is 4 bytes. So you are trying to assign a value which is of the type which is of the size 8 bytes into a variable which is of the size 4 bytes. Obviously there would be loss of data, and in order to avoid this, compiler is giving us this issue. तो first तो डेवलपर को ये रूल ही पता होना चाहिए. सेकेंड चीज जो हम लोग यहाँ पे कर सकते हैं वो ये है, as we all know that this is statement with a compile time error. So I'm going to comment that statement, and I'm going to come up with this statement now. And in this statement, I'm going to do something like this. I'm going to make some changes like this. Now, once I have made these changes, let's see whether these changes have removed that compile time error from the code or not. As you can see there is no compile time error here. If you run this program, you will see the output, and you can see there the output is being displayed as 4, which means in this particular scenario, though x was of the type double, it got converted into int, and then it got saved into the variable y. This particular scenario is known as explicit typecasting. Now, why is it being considered as or called as explicit typecasting? Because here we have explicitly told Java compiler, or say in a way, say JVM, that though the x might be of some different type, I want its value to be converted into integer, and then that value is to be assigned into y. So this point is very important, and this is the way in which where you would see you would start seeing Java happening different, Java behaving different than C and C++. Okay, so once we have seen this, now let's move to the next example. Let's move to the next change. So I've said double x here, and then I'm going to come up with an integer variable, say int y. Or let's make changes. I'll make this variable y and this one as x. Okay. I'm going to say 23 here. Double y equal to 4.5, int x equal to 23, and now I'm going to come up with this particular code here. X is equal to x plus y. And then I'm going to write the code. Print value of x. So I'll simply say value of x is, here will print value of x. Okay. So now again, next question, whether this program would compile. So let's check this. Again, you can see there is an error. Again, the same error is being displayed on screen. Possible lossy conversion from double to int. Again, why did this happen? The scenario is almost the same when compared with the previous program. Here, first the right hand side would be calculated, and then the final answer would be assigned to the left hand side. Now, when we say that we are going to add the value of x and y, we know that x is of the type int and y is of the type double. So an integer value is going to be added with double value. Now we need to understand how Java compiler sees all these things. When Java compiler sees this particular statement, Java compiler follows the concept where before performing any calculations, Java would always ensure that all the operands are belonging to the same type, and then only the calculation would be performed. So Java compiler knows here that ultimately x, which is of the type int, has to be promoted to the type double, then only it can be added with y. Instead of asking y to be demoted from double to int, because when we are going to do so, obviously it is going to result into loss of data, and we have just seen that Java does not allow loss of data. So instead of asking y to be converted into x, compiler knows that x is going to be converted into double type. X is to be promoted from int to the double type. So two double values are going to get added. Final answer would always be double, and you are assigning that value into x, which is of the type integer. You are trying to assign a bigger value into small type variable. Obviously, loss of data would be there, and that's why we are seeing this error on screen. Possible lossy conversion from double to int. So I guess this point should be very much clear for you, and that's clear to you, and that's why this error is being displayed on screen. So again, if you want to avoid this, what you can do here is you can go for explicit typecasting. So I want final answer of x and y to be converted into integer, and then that value is to be assigned into x. I would do so. Compiler will stop displaying the issue, and now you will see the addition has been carried out, and then the final answer 27 has been assigned into x. Okay, so either you go for explicit typecasting here, or what we can also do is we can write something like this: x plus equal to y. Now what is this? X plus equal to y. See, you must have learned this particular operator in case of C and C++, and this operator I would write it after the program, below the program. Okay. This particular operator, that is plus equal to, or say minus equal to, or say multiplied equal to, or say division equal to, or say modulus equal to, all of these operators are considered as compound assignment operators. These operators are considered as compound assignment operators. Why they are being called as compound assignment operators? Because you can see, we have combined two operators here to create an effect. So plus equal to, there are two operators, plus and equal to, those are being combined. So these are known as compound assignment operators. So when we make use of compound assignment operator, if you want to write x is equal to x plus y, in a way, in order to reduce the code, the same can be written using this syntax also, and this we have already seen in case of C and C++. Okay, so I'm writing the same thing here. I've written the same thing here, x plus equal to y. Now if we have written this thing, let's see whether this has any effect on the final output of the program. So again, if we are of the opinion that x is equal to x plus y can also be written as x plus equal to y, so in that scenario, here again we should see compile time error being displayed on screen. But when we are going to compile this program, you will see that no compile time error would be displayed here. And if we would run this program, we'll again see addition happening. So now question comes up, what has exactly happened in this case? See, in this particular case, as we have made use of compound assignment operator here, the compound assignment operators in Java perform implicit typecasting. So implicit type conversion, or say typecasting, is happening here, and that implicit typecasting is being carried out because of use of compound assignment operator. So with this, we will have to keep in our mind that when we make use of compound assignment operators in case of Java, they will perform implicit typecasting, which might lead to data loss. So being a developer, we need to be very much careful here. हम लोगों को यहाँ पे बहुत careful रहना पड़ेगा. Okay, आगे बढ़ते हैं. Let's have a look at the next change. See, I'm going to cover that much, only that much part now, which is new in case of Java, which or rather, which is different than C and C++, and which is different than C and C++, which will show different behavior than C and C++. Okay, so I've written int x equal to 3 here, and then I'm going to write something like this. We'll say if x system.out.println, I'll say hi, else system.out.println, we'll say hello. Now let's see what output are we going to get here, or whether this program would compile. See, if you would have written this particular code in case of C and C++, this would have compiled successfully. Okay, but as far as Java is concerned, and this would have compiled successfully, yes. But as far as Java is concerned, and this particular program is definitely going to show us compile time error. See, have a look at the error here. Int cannot be converted to Boolean. So what we have to understand in case of Java is that if you are writing if statement, if you are using if condition or say if statement, the final evaluation of the condition must always be in terms of Boolean value. The final evaluation must always be either true or false. If you are going to make use of any numeric value here, which is not going to result into any Boolean value to be generated, obviously compiler is going to show us an error. So what we should do here is, instead of writing such code, you should come up with some or other such expression which will result into Boolean value being generated. So now when I have made use of greater than operator here, okay, we know that when I have said if x greater than 20 means you are asking compiler to check, or say in a way JVM to check whether actually x value is greater than 20 or not. So either it can be greater than 20 or it won't be greater than 20. So the final answer is going to result into the scenario whether either you would get true or you would get false. So if it is going to be true, hi would be printed on screen, otherwise hello would be printed on screen. So now if I would compile the program, it would get compiled successfully. And now if you would run this, you can see hi is being displayed on screen, because now we have provided proper such expression which is resulting into a Boolean value. So this point is very, very important here. We all must always understand that in case of Java, when we talk about Boolean, the value should be either true, that is true, or false, that is false. It doesn't work like if the value is 0, it is considered as false, and any non-zero value is considered as true. That used to be the case in case of C and C++, but that is not followed in case of Java. We have Boolean type, where you would either store true, that is true, or false, that is false. So we will have to keep that thing in mind in case of Java. Okay. So now let's do the next change. So I'm going to come up with two variables here. Say float f is equal to 3.4, or say float x is equal to 3.4, and then I'll say double d is equal to 5.6. And I'm going to say d is equal to d plus x, and then I'm going to come up with this particular code. Value of d is, यहाँ पे जाके हम लोग d की वैल्यू स्पेसिफाई कर देते हैं. ओके, सो नाउ क्वेश्चन कम्स अप कि यहाँ पर क्या आउटपुट आएगा. If you would analyze this particular statement, I think this should work fine, because double is the bigger type here. So float x would be converted into double x. Now those two double values are going to get added up, and then finally you are going to save that value into d, which is again of the type double. So double value is going to get stored inside a double value. So I guess there should not be any issue in this particular program. Let's check what is compiler saying about this program. And see, we have got error in the first statement. D equal to d plus x. This has compiled fine, no issues with this, because we have just seen that double value is was going to get assigned into a double value. So obviously there should not be any issue here, but we are seeing issue in this particular case. And look at the issue here. Possible lossy conversion from double to float. You are assigning value 3.4 into x. Compiler is saying that 3.4 is a double value here, which you are trying to assign into a float type variable, and we all know double is of the type of the size 8 bytes, float is of the type size 4 bytes. So assigning bigger value into a small type variable, obviously this is not going to be allowed in Java. This would never be allowed in Java. So what should we do here? instead of writing this thing, you should go for this particular concept. See, this f that we have used as a suffix, it can be capital letter also. Either you can write capital F or small f. The moment you have done this, now compiler is damn sure that you are talking about 3.4, which is of the type float. And now compiler is going to allow this program to get compiled, and then definitely this program would run also. Program run bhi ho jayega. There should not be any issue here. No issue would be faced here. So the point is that whenever you are coming up with float type variable, make sure that when you are assigning value into a float type variable, the value is suffixed using either small f or capital F. दोनों में से कोई भी एक चीज हम लोग यहाँ पे फॉलो कर सकते हैं. So all these points are very, very important here. Now let's see the last change that I want to show you. I would say short x is equal to 30, short y is equal to 20, and then I'm going to come up with short z equal to x plus y. And now we are going to print the value of z on screen. Now what will happen? See, x and y both are of the type short. So the two short values are going to get added. Final answer is expected to be short in nature, and we are assigning that value into variable z, which is again of the type short. So finally we are going to print the value of z on screen. So it is expected that the proper answer, that is 50, should be printed on screen. As such, we don't have any variable which we have all the variables of the same type. Let's see what happens here. Look at the error now. Possible lossy conversion from int to short. Now this is very interesting. Java compiler is saying that final answer of x and y, x plus y, is going to be of the type int. Now you might be wondering that why this thing is happening in case of Java program. ये ऐसी चीज क्यों हो रही है Java में? So we will have to understand one thing here, one rule here, that whenever mathematical calculations, or say arithmetic operations, you can use any word here. Whenever mathematical calculations or arithmetic operations are performed on short byte and char type values, initially the values will be converted into int, and then the calculations will be performed in Java. This point is very, very important here. Whenever mathematical calculations are to be performed, are to be performed on short byte or char type values, initially the values will be converted into int, and then the calculations will be performed. So the moment compiler sees that you are going to add two short values here, the compiler knows that ultimately whenever this program is going to be executed by JVM is going to convert the final answer of x and y into an integer value. And then when you are trying to assign integer value, and when you are trying to save integer value into short type variable, we all know integer is of the size 4 bytes and short is of the size 2 bytes. So you are assigning a bigger value into a smaller type variable, which won't be allowed in case of Java, and that's why we are seeing such kind of error on screen. So again, it is expected that you go for explicit type conversion here, and moment you would do so, issue would be removed from your program. As you can see there, proper output is being displayed. So that's it. That's what I wanted to tell you about the data types which are available in Java. We have seen lots of changes or lots of combinations here. You can always explore much more things from your side. So we are going to stop at this point only in this particular session. We'll be coming up with discussion related with various operators in Java, and then looping and conditional statements in related, or conditional structures related with Java in our next session. So I'm going to stop sharing my screen now. Thank you.